I know the main reason why Paul elected to come to Brisbane is apparently there's a big footy match tomorrow afternoon, and that's the main driver for him crossing the Nullarbor. Anyway, I've got 15 minutes, and I'll try and keep it short and sweet. I just must say that seeing everyone here is quite intimidating. We've got an incredible array of people that have undertaken these courses and under extremely onerous conditions, and I might add, with their spouses, their partners, have achieved amazing things. This is not just a casual graduation, which we have just put together. It actually is in recognition of incredible thing you guys and your wives, partners, achieving an amazing thing, which is to get these qualifications. It's not just walk through a park. As I tell everyone, and we had an accrediting visit from the Australian Accreditation Panel a few weeks ago, and they were quite shocked. They said, "This is amazing, what's happening here. These people are not just getting together in a boring online, here's a PDF file, but really getting together and achieving amazing things with real knowledge which they're applying in their work." I had a few people come up to me this evening and say to me, they've got promotions or they've changed their career and they've done amazing things. And we hear this every week or so. We get an email from someone, whether it's in Dubai or whether it's in Alice Springs or London, people doing amazing things with their qualifications and their know-how. And EIT wasn't just formed from us putting together a bunch of courses. It's been driven by probably over 500,000 students over the last 20 years have contributed their know-how and expertise, and all credit to everyone here. So just want to say a toast to everyone here. I'd like you to raise your glasses and say, what a fantastic achievement tonight, and we really do recognize that. This is impressive. I say it sincerely from my heart. So cheers to you, everyone here. Yeah. I've just got a few words to say. Cheers. Just make sure you get to know everyone at your table. Cheers them and say hi. It'll be good. Just a few words I just want to say about EIT. We've been around for quite a long time. Fortunately, the powers that be, whether it's in the UK or the States or Australia, South Africa, they're recognizing the qualifications in the sense that a lot of them have been recognized internationally. So the qualifications you have will become increasingly recognized with the various accords. Whether you're in Ireland or England, your qualifications will become internationally recognized in the true sense of the word with these various engineering councils. So things are really happening on that front. But we've also got an amazing team, and I just want to say thanks to Carolina and Paul and Bree and obviously Bryan for coming. And Brian's going to obviously have a quick chat. He's one of our really enthusiastic, passionate instructors, and that's the other thing you would find. The instructors are all passionate, as you guys are, about achieving amazing things. So they're not just academics with a PhD and no practical knowledge. They're actually people with enormous depth of experience. So you are in good hands always. And the thousands of graduates, we've probably got about 1,200 students at the moment, 1,300 students, and they're from over 120 countries around the world. So they're not Mickey Mouse just from Brisbane or from Perth or whatever. They're worldwide. So there's amazing things happening, and you are an enormous group of graduates, and you will find in the years to come that it will be definitely a qualification to hold your head proud about. Just a few words in your engineering career, because I haven't got much time. Just remain positive. I think it's really hard to stay positive all the time. Be persistent. Hang in there. Sometimes things are tough. Sometimes jobs change and companies fold. I was just talking to a colleague, Andre, early on. Some of the larger multinational companies in the world I work for, I could never ever believe with billion-dollar turnover could ever cease to exist, and yet they're not around today. They're in a dramatically reduced form. So just stay in positive all the time, no matter what happens, and make sure that you skill yourself up. Communicate brilliantly. Try and communicate. Engineers and technologists are not always very good at communicating. Communication is critical with everyone, whether it's with words or with talking to colleagues. Very important. Build value, innovation, excellence into everything you do. There's no doubt that to survive and to grow our careers, we have to be innovative, and it's something that you hear all the time, but it's definitely very, very true. The problem with innovation is that 9 out of 10 times you will fail. You will fail, and that's quite daunting because you think, well, should I bother? And a lot of people, most people say, well, I'm not going to bother, but it's worth persisting because you will have a superior outcome. The other thing which is really hard for engineers and engineering professionals is, unfortunately, whether we like it or not, business is a key part of engineering. Your wife, your husband knows that they have to pay the bills, the household bills have to balance at the end of the month. Obviously, a lot of politicians are not aware of that fact, but it is very, very true. And it's the same thing with your company that you work for. Unfortunately, they may be run by a madman or a derelict, but at the end of the day, they have to make a profit. And that's everything you do has to be aligned with that. It's really hard when you're on a site in Port Hedland and you're repairing a conveyor belt and you want to improve the operation and you don't have the money for it. It's very distressing. But unfortunately, you've got to look at everything in a business context. A few other little suggestions are, I'm not asking you to be politicians. I'm definitely not asking you to be a politician. But when you work, unfortunately, your value isn't communicated only from your projects that you do. It's also by communicating in perhaps a more dynamic way to management of what you're doing. I'm not saying to boast or to say to your superior, but it's very important you communicate your value all the time to the organization you're in, because that's how you get noticed. I'm not saying you need to shaft your buddy, but just try and communicate your value to the organization all the time to make sure that you are noticed. Other things obviously are ensure you have all the information before making a decision. We often come across problems every day and we immediately take a gut reaction to fix it in a particular way. But again, get all the information together before you make a decision. And the final few comments are obviously learning is a lifelong love affair. Obviously, I'm not asking you to give away your partners, because they're probably critical in making a success. But learning is a love affair. I spend from 6 o'clock every morning to 7, and you may say, well, I've got a luxury because I'm not fly out or whatever, but I do spend every day on a course or trying to improve my knowledge. And believe me, it gets harder and harder as you get older, I can tell you. So try and keep abreast of what's going on. I don't necessarily mean that you need to do a formal course. Probably the most formal learning is informal learning, where you actually learn from your peers. It's probably the most powerful form of learning. And that's where we learn most. But it's important to keep your career moving all the time. And encourage your partner to do the same. It's definitely a joint affair. And then the other comment is follow your heart in all that you do. You've got to have passion in what you're doing. I see every day. I mean, we've had one of our managers, his son was in his teens, he's got brain tumor. And you think these things are horrendous, absolutely horrible. We don't know what's going to happen tomorrow morning. So we've got to seize the moment today. So if you don't like what you're doing, you have to change it today. You can't wait till tomorrow. It is one of the most important things. Your life is critical, and it's not going to be here for long. You have to seize the moment today. I've had Chris at the back saying, well, he's got a dream job. When you may say, I don't have a dream job, but you have to drive yourself to get that dream job or that balance with your life, because it's all over tomorrow. So we don't have much time. It's absolutely urgent. So just final few comments before Paul kicks me off the podium here. Please let us know what you're doing. We really are genuinely interested. We've got a passionate crew of people. In fact, the online learning is probably not the key to the business, as you know. And everyone pays lip service to people, but the people, the coordinators, Bree, for example, is one of our coordinators. She is intimately and passionately involved with her students on a daily basis. And that is probably one of the key models. Obviously, we need people like Bryan to be passionate about engineering and technical, but he is supported by a passionate, enthusiastic learning coordinator. And we are very, very interested in what you do on a daily basis. So please keep sending us emails, those little bits of snippets of information. We'd love to hear about it, and we publish it on our website because we are very, very interested in what you do. It is a critical part of our identity, and we know if we are helping you, the business will grow, the college will grow, and we can actually affect a lot more lives in a positive way. So just a few final comments. Just remember, as Winston Churchill was a bit of a rogue, alcoholic, probably when he was conducting World War II, constantly drunk on champagne or whatever. But as he said, never, never, never give up. So please, never give up. Just keep persisting and improving what you're doing. And the other final comment is, only you can change your life. No one can do it for you. So you are in complete control today of what you're doing. You may not be in control tomorrow, but today you're in complete control. You can change your life. You can do whatever you want. And I think it's an amazing time. So thank you very, very much for everyone coming along here, both graduates and their partners. We do value you enormously, and we're very grateful for everyone going to trouble. Thank you very much. Cheers.
Thank you, Steve. Okay, so what we'll do now is we'll play a special message from Dick Morley. Dick Morley is known as the father of the PLC, the Programmable Logic Controller. And Dick has also been inducted into the Manufacturing Hall of Fame. So, Caroline, if you could play the...
Hello, everybody. I'm sitting here in my office, talking to Debbie, my noble and truthful secretary, and we're very proud to be part of your graduation ceremony. We like graduating people that understand people like me and the world both together. That's fascinating. EIT is your host, and we'll talk about my life, your life, and what you can expect to do. Now, congratulations, that's a big one. Go and have a party. Have a couple of drinks. Get drunk, have a headache, and invent the programmable controller. We'll tell you all about that in a minute or two. And so that's the key element. Now, I was born at a very early age. I was 8 pounds and lost weight after I was born, which I can't seem to do today. I was born on a Thursday morning about 1 a.m., December 1st, 1932. That's a long time ago. Now, you guys may not remember how long ago it was, but it was a long, long time ago. And I always wanted to be a science guy. Einstein was my hero. You remember, I don't know if you remember or not, Einstein did all this stuff from 1915 to 1930. And he just finished his work, and I was born. Ta-da! If you think about that, I'm going to try and go quite quickly through my middle teenage years. When I was born, I had no hair, and as a teenager, I had short hair because I didn't want to cut it. You know, I'm a geek and proud to be one. The interesting thing of that is I went to MIT. I couldn't touch it. Now, I got to MIT, case in point. I didn't think about it. I was in English class in my 3rd year of high school, and everybody had to write a note to the college that they were going to go to.
He had colleges listed on the board, didn't he?
Yeah, he had colleges listed on the board with a line through them. And the only one left with 3 letters MIT, which I didn't know anything about. So I said, okay. He said, you'll never get there. And I said, okay. I didn't care. My dream was different than his dream. My dream was to play around with cars, small rockets, machine tools, physics, chemistry, chemical lab, all of that. Erector sets, nobody remembers those, but I do. And I wrote away and they accepted me. And I said, well, that'll be pretty easy. It wasn't easy. MIT was hard. You carried a brick around your head, and you had to learn stuff. Since I didn't know how to study, that made a lot of problems for me. I didn't know how to study. So then I decided, get out of there and I go to work. Oops, that's even worse. Not harder, by the way. That was easy.
The bigger brick?
No, it was a bigger prison.
Uh-huh.
I was in prison. I had to get up on time. Unbelievable. Couldn't skip class. No. I had to go where they told me. I was run by accountants, lawyers, and managers, especially those terrible MBA guys. I didn't like any of that. So in 1964, I got on my motorcycle and rode off into the night. I said, now I have freedom. That was not the case. It was the illusion of freedom that I had. And I figured, now we don't make mistakes. Now everything's going to be fine, and I can go and do what I got to do. Well, no, it turns out that I made tons of mistakes. And I found out that progress is only made down the road, and the road has bumps in it. Without those bumps, you're not making progress. Don't be afraid of bumps. Don't try to make a smooth road and then go. Go first. That's what it's all about. So about 1968, I had a hangover New Year's Day from drinking too much on New Year's Eve, and I had yet another proposal to do. You know how you get the proposals and you write them out? I didn't want to do that. I'm tired. I've got a headache. So I noticed in hindsight that all of the programs I had worked on for the last 4 years had a similarity that was astounding. So I built a box that did most of those all by itself. The box cost as a component twice as much as any computer, but I was done with the job. And it had the nice thing about saying, if it takes 4 months to change an automation line to do trucks, you can do it now. Instead of 4 months, you could do it in a month and a half. That's a lot of trucks.
Did you have a specific purpose for it in the beginning?
Nope. Had no specific purpose. All I wanted to do was make money while I sleep and get rid of this goddamn proposal. So, pardon me. So we did that, and life handled pretty good after that so much. So as a result of that, not as a result, I was married before, we get married. We had 3 of our own kids and 40 other kids that we took in as apprentices, and waifers and foster children. And if my wife said, if they want to come live with us and we want them, they can come. And they were fairly successful. We were astonished at that. Then I got even older. And I grew a beard between the things, and I had a beard on my motorcycle. At one time, I had a very big beard. And then life still goes on. And finally, life today is I have no beard, no hair, and no legs, and no motorcycles. But I do look at my computer screen, and I have a ball cruising around the world, and still dream. Now, one of the things people ask me, what are your habits? I sleep about 4 hours a night. And I take 2 naps during the day. Everybody thinks you have freedom when you work for yourself, but you don't. The freedom is, oh, thank you, baby. The freedom is that, oh, that feels better, thank you. The freedom is that you have to be the first guy on the job in the morning, the last guy to go home at night, at least 6 days a week. If that's your definition of freedom, live with it.
I like your description of the house where you live, or where Shirley lives. Shirley's house is where you sleep.
Oh, that's right. Debbie's reminding me as I drive in to go to the barn. I said, that's Shirley's house, my wife's house. That's where I sleep. So anyway, if you want to learn more, by the way, teach. Teach is a wonderful way to learn. We expect to have you teaching at EIT in the near future. So get with it, learn a lot, and become smarter than anybody around you. And don't listen to fools. Fools will badger you saying, go to this party. What are you doing that for? You got to work on politics. The politics of the future is more important than the politics of today. So be careful about that. Trap you can easily fall into. What works? Everything works. We know gravity works. We know airplanes works. We know everything works. We know about evolution. We know about all of those things. But apparently the rest of the world doesn't. But we shall see. The rest of the world may or may not know that. So you got to trust yourself, not opinion. Trust fact, not opinion. That's an important problem. Remember, we, the engineers, make the world. No one else. I include farmers in this engineering. Engineering means taking something, changing it, and making it more useful to our culture, our community, our country, whatever you like. Here's a bit of philosophy. I want to give you some philosophy. I know philosophy is a bad thing, but philosophy is important. Don't go to the future with your plans. Walk over to the future with your eyes and your mind. Actually, literally go there in your imagination. Everything we build has to be 5 to 20 years of life. And if you're an architect, you've got 100 years of buildings. Go there and bring that future to the present. Don't take the present into the future. Take the future and bring it back to the present. Remember, you are the future. Nobody else is the future but you. You are the future. Not me, not your mother and dad, not politicians. And as Shakespeare says, shoot all the lawyers. Now, that means you're onward into the future. You're going to have a good ride, a difficult ride, and the reward will be something different than most anybody else can get. Dream on, sleep well, get on your motorcycle. My name is Dick Morley.
Thank you, Carolina. Now we have actually Dick Morley here from Boston in the USA. So Blackpool Collaborate, everyone's familiar with the Blackpool Collaborate. Just make sure you can hear me okay. Dick, can you hear me okay?
Dick Morley is
here. We'll have a little bit of a question and answer session for Dick. So if anyone has any questions for Dick, this microphone is connected to that. It should be in a few seconds.
One of the things I would like to repeat the question in text down in the chat room, please.
The question in text in the chat room, is that what you're saying, Dick?
Sure, come on, let's have some questions from the chat room. Let's have some questions on the audio.
Okay. Does anyone have any questions for Dick? Anyone would like to maybe start off?
One of the things I talked about earlier was...
So,
go ahead.
Maybe the first question, Carolina. First question we'll ask Dick is, what skills do you consider to be the most important for modern engineers?
Yeah, one of the things you might worry about a little bit, the most considering thing they need to consider the most in engineers is the ability to understand things, not to manipulate things. If it ain't broke, don't fix it is wrong. Always fix it. But I like to see that the thing that helped me a lot was my machinist and automotive background. I was on a racing car, and my education did not help me win races. The racing car experience allowed me to win races because I knew and understood what a race was. So that helps a little bit. The most important skill is to use God's given stuff. God has given you 2 ears and a mouth. Use them in that ratio. Listen to everybody. Don't prejudge. Listen. Let's see if we can have another question.
Any questions from anyone?
The question I am asked most often is, how do I think? And I don't know. All I know is that when you assume a solution, that's the best way to do it. And then you assume the solution and put it in the problem, and the problem will pop out after a night's good sleep.
Thanks, Dick. And the question from Chris was, do you consider a degree to be an important part of being an engineer, having a degree? Better engineer?
Hello, here I am.
Have you typed it in, Carolina?
I consider a degree. I have no degrees, by the way. I have 4 years of physics at MIT, a year of graduate school math in Massachusetts College, and many, many other things. I don't take courses often. I still take courses. I had a course in fluid technology, fluid mechanics in 1952, which I had to retake in order to write the book. I'm writing a book on fluid mechanics. Yes, fluid mechanics. A degree is important because you have the degree and it helps you get the job. But the real thing is understanding how to solve problems. And a good book to read is The Innovator's Dilemma. It's called The Innovator's Dilemma. Because the Innovator's Dilemma says that if you have the right look and the right attitude, you will win. I don't know why I don't have a degree. I just know that I have all the requirements for a degree, but I just went back. I didn't go back. I had other things to do. I've been self-employed since 1964. I retired in 1964. Wow. The degree is important, particularly a degree. I'm a big fan of distance engineering or engineering over the internet because you can do it on your time, your wisdom. I wrote a column on that, and you can have a copy of that if you get a hold of EIT. That's a good thing to have. Why you have it, how it works, and all the rest. I'm a big fan of engineering continuously. The reason I bring up the fluid mechanics, I took the course myself about a month ago in fluid mechanics. It's okay. Keep learning. Stay stupid. Use your ears. Engineering, where is engineering headed? Engineering is headed in the direction of energy. Real energy. No use for energy. We need green energy. And the best for that is, I'm going to be objection here, is atomic energy, both fusion and fission. Fusion technology, as I mentioned to you in the opening speech of this session many months ago, fusion works. It has no waste, and it's coming. The other end is you want to make sure you know about water. If you want a good job, make the oil combustible. Restore the regular energy, gas and oil, work efficiently. We have a lot of gas and oil reserves throughout the world. We can work efficiently, with little waste, and with good agendas. Don't think about the cost of components. Think about the cost of running the system. So engineering is headed over systems. Give you some idea. I had a course recently and a conference on the future of engineering software. 300 people. They had me do a session on self-programming computers. Wow. Self-programming computers. And these were regular engineers just like you and the rest of the world, and me. And we were at the room. We couldn't fit any more people into the talk. Self-programmable computers. So you got to learn how to manage the computer, not how to make it program. Management of your tool, the tool being the computer software, in concepts such as apps, cloud, apps, hacking, all of those help. But the real help is understanding what you have to do and how you must do it. So engineering is headed for systems and not into individual components. That's a question from the remote students.
Thank you very much, Dick.
They're tired after all the work the EIT put through.
That's right, that's right. All the assignments, they're getting flashbacks.
Yeah, well, we don't want to overwork them, you know, on every day graduation. What they want to do is go home, get drunk, and sleep. And I agree with them, right? Well, it's 3 a.m., 4 a.m. here in Boston. And I have an American accent, so it may be difficult to understand. Why don't we have enough for your students? One, just one. We'll sit await you. Type it in, give me a question.
Okay.
When I was in Russia recently, I teach all over the world except in Antarctica yet. But I teach all over the world, and I was in Russia. And I got to give the Russians my compliment. They were eager for technology, eager to learn, and very, very smart. And that's what I want from all of you. Eager to learn, very, very smart, and stay with it. Well, okay, I guess we're done here. Well, thank you for having me. I like these. These are my students, not yours, you know. And I'll hopefully give this graduation speech many, many times to many, many students.
We will.
How's the sound quality, all right?
It sounds perfect, Dick.
Well, I don't know if I'm a star. I'm more like a brown dwarf.
We have to unfortunately do that. Okay, now I'd like to introduce our next guest speaker, Bryan, Mr. Bryan McSweeny. Bryan's career spans over 40 years in civil transport infrastructure arena within the Department of Transport and Main Roads. Let's welcome Bryan to the stage. I think I'd like to start off by thanking Paul and Steve for lining me up to follow somebody like Dick Morley. You know, it's obviously an easy job now for me to come from the breadth that Dick has spoken about to a little piece of a career within a road transport infrastructure organisation here in the state of Queensland. So thank you very much, gentlemen. What I have seen is that the messages that you're hearing from Steve and Dick and will flow through from what I'm about to talk about are very similar. Because what I want to talk to you about tonight is the where to from here, and particularly on the need for continuing professional development. So this lifelong learning, the love of learning that Steve spoke about, is something that's still with me after 40 odd years with one organisation, and certainly is something that I think you will find yourselves will flow through the rest of your careers. Hopefully by sharing part of my experiences I can demonstrate how to improve your career prospects, I guess, through the willingness to access opportunities as they present themselves, and to recognise the benefits that flow from actively participating in continuing professional development activities. So a bit about me. The background area is civil engineering, particularly related to road infrastructure design. I gained my qualifications through distance education as well. It was by correspondence through the mail, not quite I guess in the same vein of where you are today, but very similar. 40 years with one organisation, some of my peers tend to term or use the term that I'm a dinosaur. But it's not about age, it's more about career span with one organisation, because I don't think that you'll find that in your careers, and it's certainly not something that I believe industry expects in the current environment. So I guess I've been very lucky that within one organisation I've had an opportunity to probably work in what I would term 5 different career paths, and obviously in doing that there's the need then to develop new skill sets as you move along in your career development. Obviously your career does start with the technical skills development that you've undertaken through the attainment of your qualifications at this particular point in time. And you do need to learn and apply the fundamental knowledge of those technical standards, policies, guidelines specific to your discipline. But as your career progresses, you will need to look to move upstream. And to do that, you need to gain some new skills, either in personal, or project management, or in managerial skills development as I have today. And they're totally different skill sets from what you picked up, I would assume, in the technical capability development activities that you've undertaken. So what I'd like you to do is put yourself in this picture. Seize opportunities. And remember that they don't have to be extraordinary. It is sometimes just the simple little things that come along from, on a daily basis that allows you to make a decision about where you want to take your career. I had heard from the CEO of a fairly common, well-known airline that spoke about opportunities like buses. There's another one coming every minute. You have to think about that and take those opportunities when they come along. My career obviously started out with a qualification around civil design, civil road design. So I did actually start out as a cadet. Again, I said, with my stage a little bit smaller than Dick's. Worked primarily here in Queensland, obviously. Southwest, Roma was the early days. Moved to Cairns in the northern part of the state around the wet tropics midway through my career, and then came back to Brisbane sometime back there in the early 80s. We started part of one of my signature projects, I guess, and it shows you how old I am, was the original Gateway Arterial. That has probably now been rebuilt a number of times since my original design was actually constructed. So it's the other thing that you will learn about your career is that whatever you design and build, and as engineers we tend to look at them and say, I built that, isn't that great? Over a period of time, somebody else will come along, redesign it, rebuild it, and your little part of the world disappears. I've had a role in road design software application, installation and development. As I say, very narrowly focused on our part of the business, but again, that opportunity to be involved in a different career path, still aligned to the civil engineering, road transport infrastructure part of the business. But here I was suddenly finding myself taking an opportunity to install, for old heads in the room who may remember Unix workstations as the first standalone PC. I was there installing Sonos operating systems and the road design applications that went with those. Over a period of time that evolved into the Windows platform. So actually then now working on installation of road design software applications on personal computers with the Windows applications. From there I moved into management of a design office here in Brisbane. I was looking after 28 staff delivering road infrastructure projects here in the southeast corner, and then moved from there back into the manager of the CAD team. So I was still back then into the software application side of the business. My current role is a road design occupation group leader, which is a very nice title, I guess, for somebody who looks after the capability development activities for our new and emerging graduates in the organisation. So very much like what Steve again was talking about earlier, is this need and love for teaching and learning. I think we find it in all of ourselves at some stage of our career that that's where we want to be. We want to be back there, passing on our knowledge to the new graduates like yourselves who are coming through in the industry. So each one of those then has a different requirement about what skill set you need to apply. Obviously the continuing professional development part of that is the message that I'm spelling tonight. What I really need you to do is to challenge yourself to succeed. In every role you undertake, strive to be the best that you can. You'll find, obviously, that you need to develop new competency sets to do that. And you have the ability to learn yourselves through undertaking these activities. Continuing professional development, sometimes a term that's a little bit misunderstood. It's not necessarily the formal training that you need to undertake. It is about attending seminars, conferences, forums, technical documents, reading technical magazines. Again, there's a methodology for gaining knowledge about what's happening in your industry and keeping yourself abreast of the new and emerging technologies. You need to push your own boundaries. That is really where the challenge lies. If you want to succeed, you really do need to stretch yourself. Don't sit in the comfort zone. Don't be afraid to take risks. I think we spoke about failure, or Dick might have mentioned failure. Don't be afraid. I don't know if I necessarily want to agree, don't be afraid to fail, but don't be afraid to take risks, because in taking risks, you earn the greatest rewards. Probably the other point that I'd like to make there is, while it's worthwhile to actually set goals, to have a vision about where you want to be, always remember to be flexible and take opportunities as they arise. Certainly within my career, I didn't plan to be where I am today. Certainly wouldn't have thought it when I was a young cadet, when I was starting out in Roma in the early 1970s. But what you do is you need to take that opportunity when it arises to say, here's an opportunity, let's take it wherever it will take me, and be prepared to follow it. What we do then is actually talk about, in the engineering fraternity, is talk about transferable skill sets, because you have the technical knowledge gained from your qualification. But what underpins that is this idea of transferable skill sets. What works in one job opportunity from this perspective will work in all. Paul didn't mention it at the start, but I am a member of Engineers Australia, and I'll talk about that in a moment. But part of what Engineers Australia has done is defined a competency framework for each level within the professional engineering standard. There are three. There's the professional engineer, there are engineering technologists, and there are engineering associates, and I'm an engineering associate. But we have these technical competency frameworks that we all try to work through and make sure that we're competent at. And we start with the personal commitment. You need to understand that we need to deal with ethical issues when making engineering decisions. We certainly understand that we need to practice competently in our field of endeavour, and that you take responsibility for your work. There's also an obligation for community to develop safe and sustainable solutions, engage with relevant stakeholders, manage risk, and also to meet your legal and regulatory requirements. There's value in the workplace, and this was spoken about earlier on as well. Add value to your engineering team, and how do you do that? Communicate effectively. Always take the opportunity to put your point of view forward and understand somebody else's point of view. It's not about having an argy-bargy, it's about communicating and using that to come up with the best solution. You need to, obviously, as I said, perform to the best of your ability while undertaking your engineering activities, and exercise good judgment when you are making those decisions. If you undertake all of the other pieces, that good judgment just flows at the back end. You analyse your risk, you understand where you need to be, and you're making a good judgment call at the end of the day. And obviously underpinning all of that then is your technical proficiency. So maintain the knowledge of your standardised practices in your particular area of discipline, and that is done through continuing professional development, as I said before, the seminars, the training courses, the trade magazines. Thinking a little bit there where I was talking before, you need to understand local conditions. Working southwest, out there in the Roma area of Queensland, up to the wet tropics, back here to an urban environment here in Brisbane, you can face the same sort of engineering decisions, but they need to be dealt with in a different manner depending upon where you are. So you need to consider those local considerations. So again, part of there earlier from Steve, the great challenge for engineering roles within any business is about analysing and solving problems. I think most of us, I don't know if we've ever sat down and done the Myers-Briggs piece on this, but we are analytical people, I find, in engineering disciplines. For whatever reasons, we tend to congregate that way. We do need to have the technical proficiency to use the technological equipment available to us skillfully. And as I said before, evaluate the outcomes of your engineering decisions. You know, as I said, I am the 2013 Engineers Australia Engineering Associate of the Year. I'm very lucky to be judged by a panel and received that award last year. So I'd like to talk to you now very quickly about Engineers Australia and what they're about and my membership with EA. So Engineers Australia is constituted by a royal charter to advance the science and practice of engineering for the benefit of the community, by educating our members and the community itself, by facilitating the exchange of ideas and information, encouraging the development of knowledge and competencies, and setting and maintaining high professional standards for our members. The question that most of us seem to be asked at some stage is what is the value proposition for you as an individual to belong to an organisation like Engineers Australia? And from my perspective, and again, this may be where the dinosaur part comes in, but to me it's actually about being a member of an organisation whose members are working towards improving the social, economic and environmental fabric of the communities in which we live. It's really at the heart of what we do in engineering. Engineers Australia does assistance provided to members with the opportunity to participate in managed continuing professional development activities. So EA does actually put that out there for organisations to engage with EA to work through a managed program. And it does provide members with the opportunity for competency assessment then that leads to chartered status. And you need to understand the value that that can bring in a competitive employment market. So if you're a member of Engineers Australia and you are chartered, then in some way, most organisations recognise the value that you can bring to their organisations. In conclusion, I'd just again like to thank Paul and Steve for the opportunity to have a chat to you tonight. Struggled a little bit, I think, to find a bit, but I do appreciate it. But anyway, congratulations on your achievements to date, and I wish you all the best for all your future endeavours. So thank you for the opportunity tonight. Cheers. Thank you.
Thank you very much, Bryan. The next speaker is another Bryan, although differently spelt. I'd like to introduce Bryan Hobby. Now, Bryan Hobby is one of our best instructors. He's very passionate about assisting the students in the webinars that he conducts for us. He conducts a great number of webinars for us. Bryan has over 20 years of engineering experience. Over to you, Bryan. Thank you.
So the theme that's running through my presentation this evening is pretty much historical accident. It's a term that people that know me well will find I use quite regularly. But first of all, congratulations to all of you on your graduation. As Paul alluded to, I teach more courses. You'll find me across DIT. I met Emma here, who's one of the students that's suffered through some of my early lecturing attempts. So, you know, in the spirit of EIT, first up we need to check, can everybody hear me in the room all right? Excellent, that's what I like to hear. So, do all of your arms work? Can you raise a hand? Does that work? Is that working? Yeah, most of them. Well, it's about the usual sort of response rate I get out of a Blackboard session. So, yes, historical accident. If you check it forward for me, please, Carolina. Right. So, some words from Steve Jobs up there on the screen. I'm not going to read through them, but it's all about the path that you take in life. Okay, where you've come from is the accident that's formed where you are now. Okay, so I look back at my path, and it comes through the Royal New Zealand Navy. It comes through Rio Tinto. It's now sort of ended up here with EIT lecturing and also at Griffith University. And you're all here, if you read through the board up there, with Steve Jobs talking about dots that connect together as you look backwards. So your graduation is another dot on the path through your life. So you just put another one of those dots. We don't know where it's going to lead you. We don't know what it's going to mean. but you just put another dot on the path. But when you look back, you go, it's obvious now. Yeah, that's a historical accident. I now know what that dot meant. So historical accident. All of us have been out on site, and we go, why do we use Rockwell here? Well, it's because the first person that bought PLCs bought Rockwell, and we bought them ever since. Why do we label all of our cabling in a certain way? Well, it's because the first draftee that did the first drawings on site labelled them this way. So we've done it that way ever since. It's a historical accident. In Rio, where I worked at the smelter down in Tasmania, why is the first reduction line that makes aluminium named 2? It's reduction line 2. And if you look back into history, the site existed and started in 1955. And it started with reduction line 1, and it had 3 buildings, A, B, C. Now, they then tore that down when they made the next ones. So it starts at 2D. And if you don't know that, if you don't know the historical accidental reasons for why the first building is called 2, you're left wondering. So often there's reasons in the past that brought you through. Again, there's no building called I. It's because it gets confused with 1. So, they've gone, it's like many superstitions around. Many hotels don't have a floor 13, for example. It's a historical accident. Again, why is power 240, 50 hertz here? Because, that particular commercial company got here first, and that's what the generators make in Australia. If you're in the US, it's different. Again, which side of the road? Historical accident. Who invaded the country first? So, the other note, if you look at my tool shed at home, you go, why do we have this particular tool? Well, it's the projects I've done around the house getting to the current point. My wife often says to me, the reason you choose your next project is because you look in your shed and you go, which tool don't I have next? So what project am I going to be doing next to get the tool I want? So how did I get to now? What's my historically accidental path? So I started life as a weapons electrical engineering officer in the Royal New Zealand Navy. That's south and up there at the top of the board. So that's I'm fully qualified as the head of department on that ship. So that ship ran rocket-propelled torpedoes in an anti-submarine frigate. So my background is weapons, it's hydraulics, it's control systems, it's communications. It's all sorts of things. So from there I moved through to Rio Tinto Alcan, as it's now called. And you see in the middle there, the aluminium smelter. So I spent 17 years with them. And that crane that you see changing anodes there in the image and the robots, that's part of a prototyping project that I did to attempt to fully automate that process. So, that's all running on PLCs, vision systems, all sorts of bits and pieces. So due to the ups and downs of the market, my role at Rio disappeared, and I spent 6 months at home. And as I'll allude to in the next page, one of my contacts in part of my area said, you should talk to EIT. They need lecturers, you'd be good at that. So that's why I'm here. Again, another historical accident. Who do I know? Who do you know? Who's going to find you your next role? So at the moment, as we get to now, you'll see Griffith University and EIT down the bottom. Those are my current paid jobs. So my current jobs, as I term them, are up at the top. Stay healthy. It's important. If you're not healthy, you don't have anything. So critical for me, my wife and my son. You get me tonight for a very, very special request because I currently have a show on down at Chelmer. So community theatre, lighting and sound design, that's another one of my jobs. Not paid, but very, very rewarding in the community. So if anyone's in Brisbane and needs some advertising material, see me later. So again, tech. If anyone that's spoken to me or listened to me in my lectures, I have a very deep technology stack around home. I have multiple computers. I have virtual machines running all sorts of operating systems. I really enjoy that space. But again, it needs to be appropriate and it needs to be in date. My current phone is an iPhone 4 because I can't justify a new one yet because it still works properly. So down the bottom, now I am literally a lecturer for EIT because of somebody that I know in the community theatre. One of the other techs there is a chemical engineer, and that's my connection. So never overlook any connections. So all the connections that you folks are making in the room tonight, pay attention to them, be aware of them, keep in touch, because you never know where the next step along your path is going to come from. So standards, CBPs. Again, this is on the line of historical accidents. Everyone goes, we'll make it to the standards. Where do standards come from? In the centre here, we've got, their practical and possible goals. So based on sound, industrial, scientific, and consumer experience. Well, experience says to me historical accident. We broke it once, so we made it better, and we figured out how to do it. Okay, so that's where a lot of the original standards are coming from. You look at things like concrete. The original concrete, it took years to figure out how to make it right to build bridges out of it so that they could take loadings, and it took years of development before we shifted from just rebar to things like, putting carbon fibres and fiberglass and all sorts of other interesting things into the concrete to make shapes that, now you make stuff with concrete you wouldn't have considered years ago. Likewise with electrical standards, networking standards, they keep changing, they keep moving. What is in the standard keeps shifting. Any standard that you look at is a living document. It is the current best practice of the knowledge we've gained from historical accident. So question for you all out there, feel free to go out. What do you people in the room consider accurate if you were measuring something? Any thoughts? Give me an answer, a number. What do you think accurate is? Don't be shy. Well, that it works is good, but what's accurate? Any people willing to hazard a guess? What's that? No errors. Well, measurement-wise, I'm thinking meters, millimeters, parsecs for the space people. So what are your thoughts? So what do you think is accurate? What does your background tell you is an accurate measurement? Well, that's like how long is a piece of string. The correct answer to which is twice the length from the end to the middle. Exactly. So, okay, accurate. So take that thought in your head and go, okay, what do you think accurate is? Now just hold that thought. So when I come for weapon systems and I'm looking at putting a 4.5-inch shell 20 nautical miles over the horizon, I'm working in arc seconds at the top. 3,600 for the degree. That's very, very accurate. Then you move down to machining, milling machines, you get down to microns. Okay. Your concreting, plus or minus 5 mils, usually good enough. You get down to open cut mines. Meters will usually do for most of your bits and pieces. So again, depending what industry you come from, what historical accidents have driven your outlook on life as to what is accurate. It's that whole part. What's your sum of experience? What does that mean that you bring to your table? So in my case, when someone says accurate, I think arc seconds. So I was in an aluminium smelter, and they're saying we need to position this really, really accurately. So I had a look at that and went, what do you mean? And I looked at the mechanical engineer next to me who came out of CNC machining. He works in microns, okay? And he goes, what do you mean? They said, well, we need plus or minus 5 mil. And we went, oh, that's easy. So again, understand where you're coming from. What historical accidents have driven your thinking engineering-wise? If you're a carpenter, every problem looks like a nail. If you're an engineer and you do CNC machining, everything looks like a CNC problem. Be aware of your thinking. So the one constant I've seen is change over time. Okay, it's not the same everywhere. I talked about concrete and I talked about IT. When I first cut my teeth in IT, I was dealing with 8086 processors. Okay, there's God knows how many thousand times as much processing power in here is one of the things that I originally coded. So it's phenomenally fast in technology. Keeping up to date is very, very difficult. And as Dick alluded, try teaching the subject if you really, really want to understand something. When I'm prepping for a lecture for you folks, I have to go back and go, what are they going to ask? Do I know that? Do I understand that? Can I answer that so they can understand it? do not underestimate putting your hand up in front of a teach. So yes, down the bottom, yes, professional development. Yes, look for it. Keep doing it. So industry silos. This is something. So what industries have we got out here tonight? I know I've spoken to people out of oil and gas, mining. What else have we got? Energy, debt. So you'd all know that in your industry, do they actually look outside it? If they're doing something in energy, do they just go and talk to other energy companies? Or do they go and talk to defence or automation or somebody else? Because my background's defence, so that's one of the silos I've worked in. I've worked in the aluminium industry, that's another silo I've worked in. I've stolen shamelessly from the automotive industry, and now I'm at Griffith University in building management. So, yeah, I haven't been across all of those. There are things that are applicable. I got to Griffith and looked at buildings and went, my God, we're 20 years behind the control industry in building management systems. You know, talk about open connection protocols. You know, I got to it and went, okay, do you have data? And they went, no, not yet. So one of my roles at the moment is putting an electrical meter that is connected to the network that we can get information out of into all 120 buildings across 5 campuses here in South East Queensland. So how I've got to put that data somewhere, and then I've got to make sense of it. So, you know, what these folks are going to live with is the historical accident of what I've called everything and how I've done it. So in 5 years, when someone comes back to look and go, why did you do that? Well, because Bryan decided we're doing it that way back then. So, you know, be aware, when you're building something, when you're designing it, you're leaving your historical accidents behind for the next guy. So again, be aware of the silos out there. You know, look for the cross-pollination. You know, look for how you can, you know, steal shamelessly from other places that have already done it. You know, see if you can find a solution that's already fit for purpose out there. So a couple of war stories from me. This is one that turned up very early. This is stealing from automation and putting it in aluminium. So DeviceNet's a field bus network. Instead of having tons of copper running around bringing in lots and lots of sensors, you put in a nice little 4-wire cable around the place. Now, if you're replacing cranes in a building, taking hundreds of kilos of copper out of it is a really good idea. So we went, yeah, this looks good. Will it work? Now, what we did is we went off to an automotive plant, you know, up there on the right, looked at their welding robots and said, well, they're using it around here. You know, welders generate lots and lots of magnetic fields. It works here, right? You know, you can see this cathode ray screen do weird things as the welder, you know, fired up. So, right, does it work? So what we did is we grabbed, you know, borrowed some from the vendor, and we brought it down to the reduction line. Now, these bus bars up here on the screen are carrying 120,000 amps DC. So we took the cable and we wrapped it around the bus bar and we connected up to relays and inputs and outputs and, you know, computers and control systems, and we tested it. And it worked fine. Some of the relays were a bit dodgy. When you've got that much current, if you turn your relay sideways, it turns on all by itself. So it gets interesting. So it's about going, well, has someone else done it? Can we borrow it? Can we put it in there? But in an engineering sense, always test it. Make sure it's going to actually work in your industry, because sometimes they don't. The other thing to be aware of is the salesman knows best. While we were testing it and getting to that area of, you know, can we do the automation, we had a guy tap on the door and went, rugged laptops is the new thing. They'll be good. Yeah, we've got them sealed up. They'll work in your environment. No problems at all. You know, we've got the hard drive inside a cage. Not a problem. Should be right in the pot lines. We said, are you sure? Yeah, we've got 120,000 amps. There's a lot of magnetics down there. Yeah, not a problem. Asked him 3 times. Said, you sure? You're happy for us to take this out into the pot line and start it up? I had a fair idea what was going to work. So as soon as we started the hard drive, it started spinning in the magnetic field. Yes, it's inside a box, but it wasn't, you know, it was a reasonably sealed box, you know, electrically, but it got to that little wee prompt at the end where it says, you know, firmware loading, and then you start to get an operating system. Nothing. Nice little wee blinking cursor. We sent it back to him and he went, the hard drive's completely blank. He went, well, we did warn you. So when the new solid-state drives came out, we were on them as fast as we could. The first rugged laptop that actually worked in our industry was the first one with a solid-state hard drive. It cost about $12,000, and it could run the PLC programming software, and Windows 98 SE, and that was it. We had no room for Notepad or Minesweeper or any other packages. We've got the operating system and the programming software and one program, and then it was full. But it did what we needed to get automation into the production line. So yes, assumptions from salesmen. Be very, very aware of glossy brochures. Whenever I see a salesman, I say, "Give me the specs, please. Can I talk to your engineer in the back room to find out how it really works?" Another quick one about not making assumptions. Where to put a crane into a building. Our buildings look like this, big portal crane buildings. Our very, very insanely attention to detail draftsman went out and measured it and went, "Yep, this matches the drawings." And then instead of just going and assuming that all of them are the same, he went down the building and measured across all of them and went, "Hang on, the frames in the second half of the building are different to the frames in the first half of the building." Now, we were putting new cranes into here, and our tolerance was 50 millimetres, this much, on about a 14.5 metre span. So the problem with the portal frames being different, we found out, was that they built the building in two halves. They built half of it, got the production line running, and went, "Right, we've got more money, we'll make it longer now." And when they went to make it longer, they couldn't get the same steel. So they used different I-beams. So they were bigger. So they protruded 25 mil further in, which meant we lost half of our tolerance. So, by paying attention to detail and not assuming, we found that by historical accident, our portal frames were completely different in half of the building. Now, we got down to the point of asking the manufacturers, "Are you sure that your electrical cabinets are actually square? Do they have round corners? Because if they've got round corners, they'll fit. If they don't, they're not going to." So, when you start looking at some of these details, you start, in order to actually make that crane fit, we ended up running it very, very slowly down the entire length of a 500 metre long building with four of us standing on top of the bridge, one of them with a gas axe, ready to cut off anything that didn't fit. So, it becomes very, very interesting when you're doing commissioning work. So, things that I watch for, just to round up. Okay, whenever I'm going out doing engineering, I'm always looking for people that go, "We've always done it that way." I'm looking for what historical accidents have driven us here. And if the answer is because Bob said that that's the way we do it, and we've always done it that way, then we might want to go and ask, why did Bob decide to do it that way? Is it the right way still? Okay, again, I was talking about accuracy. What assumptions am I making? What's driven me? What historical accidents have put me here that have made my brain work this way? Why am I thinking this way? And as I alluded to, where else have we done it? Who can I steal it off? So just a few thoughts from me. Hopefully it's been interesting, and thank you very much for your attention.